All right, guys, I need you to go ahead, put your test away. Yes. So you have time. You have until the day of the next test. And like you just rediscovered, you actually have until the day of the final, but if you want as many points back as you can get, you give it to me by the day of the next test, the corrections. You can always turn it in earlier than that. That kicks ass. So just to see where you guys are, we're about to get into a section that it deals with decimals. So that kind of makes sense to put it here. And the main ideas are the idea of averaging and probabilities. So let me see where you guys are with averaging, just to start with. Right? So how do you find the average of a set of some numbers I might give you? Yeah?
Add them all up, and however many there are, so you divide them.
I like it. So add them all up and divide by how many there are. Guys. So take a second and help me. What's the average of these numbers here? No.
What's 16? No, the middle. Average 16.8.
Yeah, 16.8.
4 plus
Yeah,
9.
so you add them all up.
11 plus 12.
Yep.
Plus
You add them all up. Oh,
Can I talk to my mom?
sure. So you do 4, 9, 11, 12, 48, divided by 5. So I think you get 84 over 5, which comes out to be 16.8. So, I mean, I just gave you a big talk about averages. I had a whole sheet of averages like crazy. So you see averages all over the damn place. To be honest, the word average means more than what we just did. The real word for what we just did it's called the mean. The mean of a set of numbers is what we think of when we say the word average. The word average is actually a more general term. So let me ask, some of you guys should be very, very, very aware of this. I would never describe home prices in, for example, La Jolla by using the average. I wouldn't use the mean. That wouldn't be honest, right? I don't know if you guys see what I'm saying. Or the average income at a business wouldn't be honest. If somebody came to my business and said, "How much money could I expect to make?" And I said, "Well, the average income here is $180,000." He's like, "Holy shit, yeah!" But that's because the average includes everybody, including little Mr. CEO making, $800,000 a year. You guys understand? Do you understand what I'm trying to say? So the average is an attempt. Any average, the mean, and the other things we're going to talk about, is an attempt to figure out where the middle of a set of data is. So when I'm talking about something that's got what's called outliers, outlier, I was thinking about Children of the Corn or something. We have your moment. So let me give us a really, really silly example. Say you got a little tiny company of 5 people, and one guy makes $40,000 a year, somebody else makes 42. This lady makes 47,000. These are all thousands. You with me? Otherwise, you're like, why the hell would I work it? 47 bucks a year, yeah. 50,000, and then the CEO makes 700,000 a year.
Yeah.
So help me out again. Figure out the average, the mean of this. Figure out the mean of these. Should be good.
So we add them all up and divide it by the number.
Mm-hmm.
The last 70 or 700?
700. Oh, I forgot what it was.
175.
That sounds about right. 170.
5,800.
All right. 175.8 or 175,800. So if you told somebody comes in this, and we're about to hire one more person because we did pretty well last year, and we're like, all right, let's hire one more person to help us out at our very expensive lemonade stand we're running. We hire one more person, and the guy's like, well, how much money can I expect to make? Well, if we tell him this number, is that honest?
No.
Hell no. But is it still an accurate mean? Is it? It's the average. It's the average. But of course, what throws it off is the outlier. It's the extreme value. So we have a different way. So the mean is the most accepted, the most generally prevalent way to figure out the middle of a set of data. We hear about averages all the time. But you can see sometimes they're not really honest. So if you ever pay attention to, there's this thing called the newspaper, and they, or articles online, and they'll talk about the median income or the median home price. So the median is a different way to figure out the middle of a set of data, right? So the median is just the number that's in the middle. So notice here there's 5 numbers. Also notice, very important, are they in order? Yes. If they didn't have to be in order, I could make the middle number anything I want it to be. That wouldn't be fair. So what's the very middle number in 5 numbers?
47.
Yeah, the one right there. So 47. Now, isn't that a much more accurate expectation I can give this person? Oh, we make about 47,000. So when there are these extreme values, the median is a more honest representation of the big chunk of the data, right? That doesn't mean that the average, what we call the average, the mean doesn't mean shit. It just means there's another way to look at the middle. So the median here is 47,000, right? It's the number that's right in the middle. You guys see that?
Yeah.
So then your next natural question might be, well, that's easy when there's an odd number of numbers. If there's an odd number of numbers, there is one that's in the middle. If there were 4 numbers, which one's in the middle?
I see it. Yeah. 203.
That 6th finger that I had to have chopped off now. Right? No.
2 and 3.
Yeah,
2 and 3 plus and divided.
Beautiful. So you actually, so watch. Does that make sense? Everybody understand what's happening? If I have 4 numbers, there's no single number in the middle. So if I average these 2, that will definitely be like the most middle thing, right?
Yeah.
All right. So, but both attempts are trying to get the middle of the data. So if I had this data, for example, go ahead. I had 7, 11, 12, 17. And they said, what's the median?
11 and 12.
Yeah. So you would take 11 and 12, you'd average them,
11 and 12.
because to find the middle, this is very interesting. Given any 2 numbers, how do you find the exact middle number between those 2? You average them. I don't know if you guys knew that, or does that make sense? I average the 2 to find the exact middle of the 2 numbers. So 11 plus 12 divided by 2 comes out to be 11 and a half. Or you can just think, what's right in between 11 and 12? 11 and a half. I like it. So the median of this set of data would be 11 and a half. Are you guys still with me? The median always tries to find the exact middle. The average tries to find the middle according to how big the values are. Does the median give a shit that that's 17? What do I mean by that? If I made this 1,798, what's the median? 11.5. So it's not affected at all by extremes, right? This guy, if I made this 7,000, that is going to become very different. This is going to be the exact same. It's not going to give a shit. So that's why the median is what I report when there are extremes, because the median doesn't give a shit about extremes. Yes, sir?
Did you divide it by 2 because there's 2?
Yes, that's the nice way to look at it. The quick way to look at it. So it's to find the middle of 2 numbers, I average the 2 numbers. Or just, you don't have to do this. If you know in between 11 and 12 is 11 and a half, bam. Because that's all I'm trying to find, is the middlemost number. All right, how are we doing so far? So we got mean, which is the same as average. So all of you should have come in knowing something about how to find the average of numbers. The median, which might be new, but hopefully you've heard of the median before. You've either read it in those weird newspaper things, or you've seen it somewhere. Median income, median price, median whatever. And then there's another one that's called the mode. So we got mean, we got median, and we got mode, and this is just a number that occurs the most. So for example, for all the set of data that I put up so far, there is no mode. Right? There is no mode. Because there's nothing that repeats. There's nothing that appears more than anything else.
If there was another 4 right there, that would be a mode.
I love it. So if I had like 4, 4, 9, 10, 11, the mode there would be 4.
If there's no mode, you just put no.
You just put no mode. Exactly.
Would there ever be 2 doubles?
Totally. So this guy right here, the mode is 4. If I had this one, 4, 4, 9, 10, 10, 11, what's the mode?
4 and 10.
4 and 10. Beautiful. There's no the mode. It's actually what's known as bimodal. Like bicycle has 2 wheels. Bimodal has 2 modes. So the mode would be 4 and 10.
So you don't add it?
No.
Okay.
So what the mode does is it tries to see where the data seems to be clustering. Like at a college, I would expect the modal age in an introductory class to be 18. Maybe 18 or 19. You guys understand? Because in intro class, there should be an overprevalence of people that are just coming right out of high school. Right? So I'd expect the modal class to be there. Now, a class that's a little higher up or something, maybe the modal class could be almost anything. Because then you have all these different types of people coming in there. Yes, ma'am?
Okay, so if there's a number listed 3 times, because you said it's by, isn't 2,
Yeah.
does that outweigh?
Oh, I see. Yeah, exactly. So it's sort of like poker rules here, right?
Right.
I like it. So like if I had 4, 4. Now, so what she's really asking is this.
3 modes.
No, not 3 modes. She's asking this question, right?
Right.
Then it would just be 10.
The mode is 10. There's a winner.
Right.
Winner. Here, there's a tie. Both be winners. Right? Don't just list all the numbers that repeat. Tell me the one that won. Right? If there's a tie, write them both. Now, your question.
Mine was, I don't think they would probably, is there problems that are giving you that?
Yeah, it's called trimodal. And then after that, we just like, screw it. There's no freaking mode.
Quad mode.
No. After trimodal, we're like, no. In fact, I'm not even sure this. I don't like to even go as far as trimodal. I think this book only stops at mode, to be honest, which is good. But I kind of like you guys to know that it certainly could be bimodal. Now, let me ask you. Oh, yeah.
Go ahead.
All right, let me stop. So, is everybody? Yes.
So the median is like the middle number?
Yes.
So like for 4, 9, 11, and 12 down to the first column, you wrote right there, the median, median would be 11. right?
Yes, the median here would be 11. I like it. Now, let me give you. Let me see if you guys can get this. What's the median of this set of data?
4.
Yeah, actually, you're right, but for the wrong reason. Let me do this. All right, what's the median of this data here?
19.
All right, now you're wrong for the right reason.
It's 7.
So again, if you can make the median any number you want to, why the shit would we have the idea of median? So the data has to be in order for it to make any sense. So I've been nice so far. Everything I've put has already been in order.
From least to greatest.
Yeah. So 0, 2, 7, 11. When I had a 4 there, it just happened to be coincidental that, yeah, when you put it in order. So now you can see the median is 7.
Because then that brings up the point, like you said it earlier, like you could have a random number in the middle, like $1.
Yeah, I could rearrange them however I want to and then say that's the median, and that sounds more like what's actually going on nowadays in government. But it's supposed to be in order because then it makes sense. 7 is in the middle of the data. 19's not in the middle of this data. Doesn't make any damn sense. If somebody wrote this out of order. Put it in order, now you can see 7's in the middle.
Yeah.
Yes?
How was that one in order? 0.
How is it not in order?
No, wait, no, that one, oh, you're talking about the bottom,
Yeah,
right?
so this is no good. I can't tell.
I was talking about the
I can't tell the median from this, so I have to write it in order. Now I can tell the median is 7. Yeah. I like it, I like it. Yes?
Why is that 7 and that's 11 and 12?
What happened?
Because the median.
Oh, so again, is there a middle finger in my 5 fingers?
No.
Yes, there is. There's a middle finger. Is there a middle finger in these 4 fingers? No. So what's the middle? It's the middle of the 2 in the middle. So when there's an even number of numbers, I have to average the 2 in the middle. Right? Now I know I normally talk really fast, but notice how when I talk really slow, that's a good note to take. So when there's an even number of numbers, the median is the average of the 2 in the middle. When there's an odd number of numbers, there is 1 in the middle. That's that one.
So when it's 6, we'll do the same.
Yeah, if there were 6, you'd have to average the 2 in the middle.
Okay, yeah, makes sense.
The question is, like if the data is like not like in the order, and if you have like 4.
So let's see. That's not too negative, Jeff. Yeah, good. I like it.
Let's say like we have like 4.
Well, here's 6. It'll still work.
Okay, yeah, 6.
Yeah. So take a minute and see if you can figure out.
This one.
Let's do all 3. The mean, the median. Well, I made one. What's the mode?
The number there's no mode.
No mode. Okay. So figure out the mean and the median. What are you guys getting for the mean? Well, no. So when you add them all up, you get 38. Then you have to
6.3.
yeah, 6.3. Yeah.
6.
Divided by 6, so you should be getting 6.3. Repeating, right? Put a little bar over that to make that quick, so you don't take the rest of your life writing 3s. Everybody cool so far?
Yeah.
So again, the average. So I really want this. Let me just do a little side note on average. Actually, let's just finish this up real quick, and then I'll do a side note on average. How do you find the median? What do I have to do first? Put them in order. There's 6 of them. So watch this. you can count in and go, oh shit, it's the one in the middle of 5 and 7. But of course, what number's in the middle of 5 and 7? 6. So don't even make your brain think that there's a process that you must always follow to get the mating. No, it's the number that's in the middle of the two in the middle, right? If there's an even number. So I can just see it's 6. Don't waste time doing 5 plus 7 divided by 2. You know it's 6. So 6 has got 3 above it and 3 below it. So it must be the number that's in the middle.
If you take same number, no 1, 3, 5, 7. You take 1, 3, 3, 5, 7, 8.
Wait.
1, 3, 3, 5, 7, 8.
Sure?
Yes.
And?
And take this 3 and 5. 4.
4.
Here.
That's the median, yes. Cool.
If you
Yeah, 'cause,
see same number, you see same number.
Yeah. The median doesn't care
Don't care.
about the values. It just cares to find the middle thing. What's in the middle? 4 is in the middle.
4.
Because how many is above 4? 3. How many is below 4? 3. So it's right in the middle, ain't it? And if I had 5 numbers, how many is below the third one? 2. How many is above? 2. So that's in the middle. Yeah.
So if it's 6, you wouldn't have to divide 6 again to make it, it's just 6.
No. What number's in the middle of 5 and 7?
6.
6.
The reason is because he added 5 plus 7 is 4.
But what's in the middle of 5 and 7? I didn't even do that. What's in the middle of 5 and 7? 6. But if you did the process, you do 5 plus 7 is 12, divided by 2 is 6. Of course that process works. It's just more than I needed for this. What is that? I'm eating spaghetti up here, right? Yeah.
Do you do do you have to, do you figure out the answer without putting them in order?
You'd have to put them in order in your head.
The
You
only-
still have to put them in order. You see what I'm saying?
So right there, you can't, from right there, you need 14 and 5 and 1, 3, 7, you can't.
Tell me how you would do it.
No, I'm asking you, that's why, I don't know how to do it, that's why I'm asking you.
Oh, I don't know how to do it either. So,
Well,
I
neither
mean,
do I.
how do I know what to average if I don't even know what the 2 in the middle are? And how do I know what the 2 in the middle are? There's no other way except to put them in order, right? So I appreciate trying to figure out like a shortcut to this, but there is none. You have to do it, put it in order first.
That's
Yes.
what I'm looking at it, if it was with the other one, how we just had the first, median that you wrote, no, when you put the 4 and everything, that we just looked at it and we knew that it was 4.
Because it already was in.
No, not that one, the other one, the one that you put a 4 and then you put a 19, remember?
Oh yeah.
Yeah.
Because it just was coincidence that the 4 would have been in the middle. It was coincidental, right? Okay. Yeah. Yes.
I'm sorry,
So this is
like that one. On the bottom. Oh, you said you just came up with the answer 6, like I knew that as well. But would you knock this down for not showing us work for that?
No, of course not. Now, of course, what would the work be involved? If you gave me the answer 6, but you didn't show me these in order, then I would go, where's your work? This is the work.
But you don't have to show your work for why you got 6.
I really would hope you could figure out the middle without doing it yet. It's sort of like the same as, guys, it's sort of the same as multiplying by 1,000. I don't want to see work. I just want you to move the decimal over and be done with it. I'll take points off if you show me work on that. This one I wouldn't take points off, but I don't need it.
Okay.
Right? Because you should be able to figure out the middle of 2, number like 5 and 7, yeah. So I'm ready to, as a math teacher that has a shirt that says this, I'm ready for getting shit about showing work, but part of that is knowing when work is actually not just unnecessary, but shouldn't have to be done. For example, like 7 times 8. I don't want you to write 8 7 times and then add it up, right? That's valid, but it's like, oh my God, do you have to do that? That's worrisome for me. So there's that distinction between the work I have to see and the work that you shouldn't have to do. So yes, a part of that is actually figuring out which is which, right? Okay. Let me see, was there something I left out? No. Okay. So we did mean, median, and mode. So you need to know what those mean and how to find them. Now I'll talk a little bit about probability. Let me just see what you guys already know about probability. What's up?
So that's 6. I'm still confused about that one.
Why?
I don't know. I have no idea. Because I did 5 plus 7,
Yes?
which is 12.
Good.
And then I divided it by 6.
Why did you divide it by 6? 5 and 7 are how many numbers?
2.
That's
Two.
what I was trying to tell
You divide by the amount of numbers you added.
So you only divided 5 and 7.
You're trying to find the middle of 5 and 7. There's only 2 numbers. So 5 plus 7 is 12. Divided by 2 is 6.
So then mean and median are different. So
Of
if it
course.
was- If it was mean, then I would just count the numbers however.
Yes. So to find the median of an even number of numbers, right? Like 6 numbers. You have to find the mean of the 2 in the middle. 2. So it's always going to be divided by 2 for the median, right?
So might as well just whatever is in the middle.
But all right, let me show you. So let's hold off on this for a second. What if my data was this? Oh, 1, 2, 3, 4, 5. There you go, Jeff. Okay. So the median. Now, what's in the middle of 5 and 7? 6. What's in the middle? 10.97 to 14.129. No. So that's what I meant by 5 and 7. I don't have to do shit. I know 6 is in the middle of them, right? Now, if you wanted to, 5 plus 7, 12 divided by 2 is 6. Of course, it gives you the same answer. Here, can you just look at that and tell me? Maybe some of you could if you sat there for a while, but why do that to yourself? Just add them and divide by 2, right? So the process works always. Do you always have to use the process? No. Sometimes I could just see it.
It depends on
Huh? Depends on the numbers, exactly. So I want you to understand, the process exists for this kind of problem. I don't have to use it, though, if I could just see what's in the middle, right? But this one, holy shit, I can't see what's in the middle there. I can estimate it right now, but I don't want to sit there and think about it. No. Okay. If I had to, I could. I don't want to. Okay. So let me see what you guys know about probability as you sit there. What really sucks is, what normally happens after test is I get fewer students who come to class. And I've lost a few that actually came today. That sucks. Let's see how many is left. 2, 4, 6, 8, 10, 12, 14, 16, 18. Not enough. There's something called the birthday paradox. If I had at least like 34 students in here, I would feel very comfortable doing this. Right now, there's a really good chance it wouldn't work, and then it's like, ooh, who gives a shit? But what happens is I would say, what's the probability that you think that 2 people in here have the same birthday? Not the year, but like June 11th or something. You would think that not very good. Right now, I would kind of agree with you that it's actually better than you think. There's a chance it would work. Once it's about 30, 34 students, there's a better than 50% chance. It's actually even better than that. Once there's like 50 students, it's almost guaranteed that 2 of them will have the same birthday. Now, real quick, the mistake our brains make is we think us. We think, nobody's got my birthday, what the hell? But how many pairs of people are in this room? A lot. I could pair everybody else with you, right? And then I can go to you, pair everybody up. That's a lot of pairs already, and I'm not even done. Do you see what I'm saying? Do you see what I'm saying? So the fact that there's so many pairs, the likelihood that any of those pairs will have the same birthday between the 2 is higher than you would think, because there's more chances for it to happen. So probability is all about the chances that something is going to happen. So the basic idea of probability, let's say I have, let's just do the really boring traditional probability problem. Right? You put 4 red poker chips in a bag, and you put 6 green poker chips in a bag. And you hold it back. Now I gotta, this is you guys maybe, you must have heard picking stuff out of a hat or something. What's the probability that if I pick one out without looking, I swirl it around and pick one out, what's the probability that I get a red poker chip?
410.
Yeah. How many chances are there for me to get a red? No. There's how many chances? 4 chances. There's 4 red. So I got 4 chances. Out of how many things that could happen? 10. So the basic idea of probability never changes from what I just said. It's always the number of things that matches what you're looking for. Looking for red, there's 4 things. Divided by the total number of things that could happen. 10 things could happen. So the probability that I get a red poker chip, that's the shortcut way to say that, is 4 out of 10. As a decimal, that is
0.4.
0.4. I like that. All right, so you see why it's in this section. It's fractions and decimals up the wazoo with probability, right? And then, of course, it's going to lead into percentages eventually for us. We're not there yet. Yes?
Do we have to put it into decimal?
It depends on what the problem says. With the homework, yeah. It says, it'll tell you what form to leave it in. What about this? I counted how many people, just a second, I forgot already. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 students in here. Anybody left-handed in here right now? Any left-handers? No? Anybody who's ever been to England? No? Anybody been to Utah? No? Yes? Hey, all right. It's so weird. You're all like clustered. You just naturally, I feel like somebody else has been to Utah. Because I've also, let me throw myself in the mix. So I've been to Utah. 1, 2, 3, 4, right? So the probability, if somebody came in here blindfolded and we all kind of like ran around the room and they reached out and grabbed somebody, this sounds horrible. What's the probability they would grab onto somebody that's been to Utah? It's the same problem, yeah. There's 4 chances, so probability if somebody's been to Utah, there's 4 chances to pick somebody who's been to Utah, 4 people, out of 21 total people. And then you can make that into a decimal if you just divide it, right? Whatever form they want you to write the answer in. And eventually we're going to go to taking the next step and make it into a percentage. But right now we don't worry too much about that. The problems for the probability don't get harder than that, really. Yeah. In fact, they get easier than that, but that's all right. Yep. Now, probability is a lot more interesting than this because you've got, like, anybody ever play the lottery? Yes. Right? And I have certainly played it every now and again, mostly just with friends or whatever. I remember when I turned 18, I was in Virginia. We went and played, like, some scratcher tickets, and we won. That's almost the only time I ever won anything was that very first time. And thank God it didn't, like, get me hooked. We won, like, $22. But for an 18-year-old, I was like, yeah. So we saved a little bit, and we bought all these other scratchers and won shit. And I think we kept like $4. And we're like, well, still $4 up. What the hell? It's all good. Let's go to Taco Bell. Sorry. Well, yeah, 18, you can eat anything. Probability with lottery is a lot more complicated formula because you could pick all these different numbers. They don't have to be in order for the lottery, of course, the way they show up with the balls popping up and whatever. People claim that the lottery is a tax on the ignorant because it's almost impossible to win. At the same time, the only way you can definitely lose is to not play. So if you got money, play if you want to. What the hell? What makes me sad is when people could be using that to buy bread and milk, and instead they're buying freaking scratcher tickets that are almost going to be worthless for sure. That makes me a little sad. But so probability gets a lot more interesting, but also gets a lot more complicated. But for us, we're going to stick with things like this. When I'm given a situation where I can just count, then probability should be easy. Right? So situations that I can't just count. The lottery, there's billions of ways to combine these numbers, so it's very difficult to work it directly.
Can you work it so we can win?
If I could, what do you think I'd be doing right now? I'd still be teaching, to be honest, but I'd be coming to class in a much nicer car. Pretty good. Probably wearing nicer clothes. yeah, it doesn't really get much more weird. Oh, they do have a, yeah. All right, so watch this. Let's say there are 285,927,500 combinations of numbers for a certain lottery. You buy 3 tickets. What's the probability that you win? It's not 0, right? Mathematically, it's not 0. 3 out of that, right? 3 out of 285. You just tripled your chances instead of buying 1 ticket. You tripled your chances. But I mean, it's so damn low. It's basically the equivalent of being struck by lightning while being eaten by a great white shark, right? Although this is a much preferred, right? And then hopefully that kills the shark and you swim to safety and you're in the news. I don't know what would happen. All right. But it doesn't, so the problems don't get harder than the ones I've shown you. So another example, I've got in my car, well, let's say this. In my car, there are 8 classical CDs.
Which one?
And I got a lot of Tchaikovsky, but I just like the overtures that require cannons to be played. So I like those, and like a mixture of Pirates of the Caribbean kind of classical stuff. So 8 classical CDs and 4 rock CDs. Good old rock is the catch-all. And it's dark. I reach my hand and I grab a CD. What's the probability that I pick a rock CD? 4 out of 12. So the big mistake you can tell, the big mistake would be somebody saying 4 out of 8. But you always got to get the total number, right? So the probability of getting a rock CD would be 4 chances to get a rock CD out of 12 total things that could happen. 1/3, blah, blah. You can make whatever. I like it. Cards are also big for probability, but I don't use them often because there are people that don't know suits and all that kind of stuff. So I try to stay away from using cards. Cool. What was the last thing I wanted to say? I can't remember. All right. Okay, cool. What time we got? Yeah, what the hell? Lost like half the class, so might as well. I think it's plenty. We'll continue moving forward in chapter 5 next time.
So this was 5.
This was 5.5. Yeah. So we finished 5.5. We haven't done 5.6 yet. But it will actually, 5.6 is going to be stuff that we're familiar with, just kind of repackaged a bit.
Yeah, it's a little weird.
It's a little weird the way that it's worded sometimes, but we'll get into it.
Yeah. Wait.
Yeah.